India has carried out a successful flight of a new long-range hypersonic cruise missile, signaling a major technological milestone in its defense capabilities. The missile, known as the Extended Trajectory Long-Duration Hypersonic Cruise Missile, ET-LDHCM, was launched on July 14, 2025, from the nation's eastern coast. Developed by India's Defence Research and Development Organisation, DRDO, under the secretive Project Vishnu, the missile attained a blistering speed of Mach 8 and struck its target precisely after traversing up to 2,500 kilometers in certain configurations. This advanced system builds upon the foundation laid by earlier platforms such as the Hypersonic Technology Demonstrator Vehicle, HSTDV, which showcased India's scramjet-powered sustained hypersonic flight as early as 2020. Unlike ballistic missiles that rely on rocket propulsion and predictable high-arc paths, the ET-LDHCM operates using an air-breathing scramjet engine. This allows it to remain within the atmosphere, drawing oxygen from the air and enabling long-duration hypersonic cruise flight with minimal onboard oxidizers. The missile structure is engineered to endure temperatures exceeding 2,000 degrees Celsius, thanks to its heat and corrosion-resistant alloys and thermal protection systems co-developed with India's Department of Science and Technology. During a 1,000-second ground test in November 2024, DRDO validated the scramjet's performance under simulated hypersonic conditions, proving its resilience and operational potential. ET-LDHCM is built to deliver warheads weighing between 1,000 and 2,000 kilograms, and is compatible with both nuclear and conventional payloads. It boasts precision navigation using inertial systems supplemented by India's NavIC or GPS. By flying at low altitudes with the ability to change course mid-flight, the missile avoids easy detection and counters interception by modern air defense systems. Furthermore, its plasma-shrouded exterior reduces its radar signature, allowing it to penetrate advanced anti-missile shields such as the Iron Dome, THAAD, or the S-500. The missile's versatile launch profile allows deployment from land-based platforms, naval ships, and combat aircraft including the Rafale and Su-30 Mki, giving Indian forces operational flexibility across domains. The combination of speed, agility, and stealth makes it a formidable tool for striking command centers, radar installations, naval assets, and hardened facilities deep inside adversary territory. Project Vishnu, under which ET-LDHCM was developed, is a broader initiative to create a family of 12 hypersonic weapons capable of strike and intercept roles. It marks India's most advanced leap into air-breathing hypersonic propulsion, moving beyond previous systems like the Mach 3 BrahMos and the ballistic Agni-5 missile. Unlike those, the ET-LDHCM is non-ballistic, maneuverable mid-flight, and capable of enduring atmospheric stresses over extended durations. Its development also aligns with India's strategic vision of self-reliance in defense production. Built at the Dr. APJ Abdul Kalam Missile Complex, the ET-LDHCM involved participation from Indian private defense firms and SMEs, aiming to reduce dependence on foreign suppliers and boost the local military-industrial ecosystem. This milestone comes at a time of rising regional instability. India continues to face strategic friction with Pakistan, which has been deepening its ties with Turkey, while China has been ramping up its military footprint in the Indo-Pacific and advancing its own hypersonic systems. The ET-LDHCM enhances India's ability to deliver a swift and credible counterstrike, reinforcing its doctrine of credible minimum deterrence and helping maintain strategic equilibrium in a rapidly evolving security environment. Beyond its military utility, the program has significant implications for India's broader technological ambitions. Breakthroughs in scramjet engines, thermal shielding, and avionics could aid civilian aerospace efforts in reusable launch vehicles and high-speed transport. The collaboration between DRDO, academia, and industry is expected to catalyze innovation, create employment opportunities, and lay the groundwork for defense exports. The ET-LDHCM's future includes further refinements, including improving electronic countermeasure resistance and enhancing guidance accuracy. It also serves as a base for DRDO's future hypersonic glide vehicles, which are projected to be operational within the next few years. Another round of flight tests is planned to validate survivability in electronically contested environments and to finalize integration with India's broader military infrastructure. This successful test, following another long-range launch in late 2024, positions the ET-LDHCM as a centerpiece of India's next-generation deterrence strategy. It sets a precedent for weapons that can maneuver in real time while flying at low altitudes at hypersonic speeds, offering a new paradigm in precision, survivability, and tactical flexibility. Compared to India's legacy platforms, the ET-LDHCM marks a distinct shift. The BrahMos, co-developed with Russia, uses scramjet technology and caps at Mach 3 with a range near 450 kilometers. The Agni 5, though boasting intercontinental reach, follows a traditional ballistic path and lacks maneuverability in flight. Similarly, submarine-launched missiles like the K-series rely on solid-fuel propulsion and fixed trajectories. Unlike these, the ET-LDHCM maintains continuous atmospheric propulsion, allowing for extended maneuvering throughout flight. This sets it apart not only from Indian systems but also from many foreign hypersonic platforms. Russia's Zircon, for example, is sea-launched and scramjet-powered but has a shorter range. The U.S. long-range hypersonic weapon employs a boost-glide approach with greater range and speed but lacks a sustained air-breathing cruise. China's DF-ZF and DF-27 also follow the boost-glide model, sacrificing continuous propulsion for maneuverability during descent. India's ET-LDHCM blends sustained hypersonic cruising with maneuverability, plasma stealth, and flexible launch options, all achieved with indigenous development. It signals India's arrival in the exclusive group of nations with operational hypersonic cruise missile technology and sets the stage for future strategic advancements in both military and civilian aerospace.